Good morning, everyone. Can you guys hear me okay? Yeah, as stated, I'm Amelia Loeb. I'm a master's student in the Small Grains Lab, and I'm really excited to tell you guys about the project that I've been working on. I'm also using drones and aerial imaging, but I'm focusing on malting barley quality. And this is the second year of this study. Hopefully I'm going to graduate in about a year or so. Since February, Felipe and I have been flying the field behind us about a week, every 7 days, weather dependent. As we're starting to get closer to harvest, we're increasing that interval to fly more frequently, or decreasing the interval. And so we have the drone and we have the multispectral camera on it, so it captures images in red, blue, green, near infrared, and far red wavelengths. And so from those images, we're able to stitch together an entire image of the field. So we fly the drone about 20 meters high, and it goes in a zigzag pattern covering the entire field. At that height and the resolution of the cameras, about every 2 centimeters on the ground translates to 1 pixel in the image. So we have thousands of images per field. We're able to stitch them together into one of the entire field. From there, we can draw the plots around the section of the field that we're interested for each plot, and then we're able to take the image data and add that to our models. And I'm really excited because this year we're incorporating the entire advanced stages of the malting barley program. So we have about 300 lines in the observation, the advanced, the preliminary, and the Eastern Malt Quality Trial. We're also genotyping all of those lines and sending it out for quality data. And one of the goals of this project is to be able to predict that malting quality faster. Malting quality is really important, but it's also a difficult data point to obtain because it's destructive, it's costly, and it takes a long time. By the time that we harvest the samples, we let the grain cure, send it to the lab, and the lab gets us that data back. We've already planted the following year. WinSeas has already made selections, and so we're not able to make decisions off of that year's quality data. So by building these prediction models, we're hoping to make decisions, data-driven decisions in real time. And that will be able to that will make us able to release better varieties faster. And with breeding, that time is one of the most important components. However, there's also a larger scale question that I think is really interesting. Felipe touched on it already, talking about, energy partitioning, photosynthesis, and we're able to look at the end use quality through stages of growth and development. We know that the environment is really impactful on that end use quality, late rains, drier winters, wetter winters, things like that. But with this aerial imaging, we're able to collect so much more data than a team of grads and undergrads could ever get walking through the field. And so that's what I'm really excited about, is learning how to build these models to make better malt varieties faster and understand more about how quality is related to the stages of growth and development. And so, yeah, with that, if there's any questions.
Amelia? Are you going to be able to since you're doing the genetic information, the environmental information, are you going to be able to parse out the genetic contribution and the environment and the G by E in there?
Yeah, we have this field replicated in Blacksburg and Warsaw, and so we're starting to look at that as well. Specific BLUPs and markers that might be responsible. But at the same time, we know it's a very, there are specific, genes and markers responsible for malting quality, but, quality in itself is a large trait made up of, multiple specific, complex. Cool. Thank you for your question.
What's your nitrogen management on this?
Oh, I'm so glad you asked.
Okay, fertilizer guys.
Yeah. Yeah. So I should say it's not my fertilizer management. But yeah, around 25 pounds per acre applied in like mid-December, 25 in February, and then 40, yeah, some boron. I can give you this, but yeah. Micronutrients, yeah, they take real good care of the fields here. Yeah. Yeah.
So what would the ideal timeline be for your ability to predict quality with this technology?
Yeah, I think ideally, like realistically as well, be able to, look at it in season, the growth curves in season, but as soon as harvest is done, be able to analyze it that summer and make decisions and selections so that when we plant that following fall, like we're up to date and we have that information. And so what we're taking, malting quality now takes couple of months, and we're trying to get that into a couple of hours or days or so, and so yeah, good question, thank you.
Are you just using malting quality as a base for greater ideas, because that's such a niche market, right?
Yeah, that's a good question. Kind of a proof of concept and exploring that larger question of how stages of growth and development, timing interact to quality. But we know that for all crops, the end use quality is the result of everything that has gone in that field during the season. So yeah, hopefully, proving that this concept works, then looking at, wheat, other crops as well. But I think there is a larger scientific question there that can be applied to any crop. Yeah.
I think you probably are going to want to look at traits that are more highly heritable, like protein content and some of the more highly heritable, and then see what effect the environment is having on those specific traits, because otherwise it's probably going to be muddled what you're going to see.
Yeah, like be more specific and narrowed it down. Yeah, thank you. Yeah.
So if you have mixed lines and you're taking imagery, so in processing data, how do you isolate to differentiate the effect of genotype on the results you get?
When you say mixed lines, can you explain?
Different cultivars planted together, randomized, and then you're taking imagery. So how do you differentiate between the lines? Say this line may be this one may be this, using the imagery there.
Yeah, excellent question. So when we have that orthomosaic of the entire field, we're then able to draw the exact plot of what each line is. So, like one plot will be Nomini, the other one will be Thoroughbred, Avalon, and so on. And from that, like, image of the exact plot, we're able to get the like image data, pixels, spectrums, and things like that. Was that your question? Yeah.
We're talking about if you plant these two varieties together. We're talking about this. If you have a mixture in the plot, for example, if you have a mixture in the field, is about this?
Yes.
Yeah, yeah. This is a good question. Maybe we can do this, but we need, for example, we need to get them images, and then we need to train maybe a machine learning model to try to identify if we can see difference between two varieties. If someone see, you have sure that the computer can see too. Okay, it's possible, but we need to train this model. Yeah, but it's possible. Yeah.
But every one of your plots are geo-referenced.
Our should, yes.
Yeah.
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 Yeah. Is that question?
Yes.
Yeah. But you need to work with machine learning models. You need to train a model for that.
Alright. Yeah. If there are no more questions, feel free to mingle, walk the field, come up to us individually. But yeah, thank you for your attention.